Pi is an irrational number as it has an expansion which is non-terminating and non-repeating. Which of the following is not a rational number? Root 25 is 5, root 36 is 6, root 9 is 3. These are all rational numbers. Now root 6 does not have any such rational number as its value. So this is not a rational number. If a and b are positive integers, then HCF of a comma b into LCM of a comma b is nothing but the product of the two integers. Next question. The decimal expansion of 93 by 1500 will be terminating. The HCF of 52 and 130, when I do the prime factorization, I get 13 2. So 52 is 2 square into 13, and 130 is 13 and 2 again. 130 is also 5 into 13 into 2. So the HCF of 52 and 130 is 13 into 2, which is 26, option C. The degree of the polynomial whose graph is given below. The graph intersects at 2 points, touches the line at 2 points. So the option is B. Other two zeros of the polynomial x cube minus 8x square plus 19x minus 12. If it's 1 zeros is x is equal to 1. We know one of the zero. So since 1 is a 0 of the polynomial, x minus 1 is a factor of f of x. Now, when we know one factor, I am going to first factorize it into the form of ax square plus bx plus c. For that, I am using the synthetic division method. So, I am putting 1 here. We have to take the coefficients of the expression. So, here the coefficient is 1. So, I'm going to put 1 here. Next, it is minus 8, then it is 19, and then it is minus 12. So now, first, we'll just put arrow and get the 1 here. 1 ones are 1. I get minus 7. Minus 7, 1. Minus 7. I get a 12. And 12 ones are 12. This gets cancelled. So my expression becomes x square minus 7x plus 12. Now from this, I can easily get my zeros. When I factorize this, I get x square minus 3x minus 4x plus 12, x into x minus 3. X into x minus 3 minus 4 into x minus 3. So it is x minus 4 and x minus 3. So the zeros are 4 and 3, which is option D. This question is wrong, so please ignore the question. For the ninth sum, if a minus b, a and a plus b are the zeros of the polynomial x cube minus 3x square plus x plus 1, which is given as f of x, then I should find the value of a plus b. So now my expression is in the form of ax cube plus bx square plus cx plus d. So the sum of the zeros of polynomials can be expressed as minus b by a. My minus b is 3. So 3 by 1, which is 3. So already the zeros are given to me. I know that the sum of the zeros of the polynomial is 3. So 3a is 3 and I've got the value for a. Similarly, the product of the zeros of polynomials is given by d by a, which is, sorry, it's minus d by a, which is minus 1. So the product is a into a square minus b square, which is equal to minus 1. So 1 into 1 square minus b square is equal to minus 1. 1 minus b square is equal to minus 1. B square is equal to 2 and b is plus or minus root 2. So a plus b should be 1 plus or minus root 2. Next question. Which of the following is a polynomial? Now, a polynomial should have a degree which should be always positive. So for here, the x has a degree of minus 1 degree. 10th question. Which of the following is a polynomial? For all the polynomials, I should have my power as positive. So this has a x power minus 1. So this is not a polynomial. 3 root x. Root x is nothing but x power 1 by 2. This is not a polynomial. Clearly I have a negative power here. So this is also not a polynomial. This meets my standard conditions. So option D is a polynomial. Is 36 minutes. Find the greatest number that will divide 445, 572 and 699, leaving reminders 4, 5 and 6 respectively. So first of all, we have to subtract 4, 5 and 6 from 445, 572 and 699. So 445 minus 4 gives 441. 572 minus 5 gives 567. 699 minus 6 gives 693. Now, for the three of these numbers, I am going to take the HCF in order to find the greatest number that will divide all three of these. So HCF can also be found using the long division method or the Euclid's division lemma. I am just going to do the normal prime factorization method. So 441, I get 7 into 63, 7 9s are 3 3s are. 441 is 7 square into 3 square. Similarly, for 693, I get 3 into 2 31, 3 into 77, 7 into 11. So for 693, we have 3 square into 7 into 11. For 567, I have 7 into 81, 3 into 27, 3 into 9, which is again 3 into 3. So for 567, we get 7 into 3 power 4. So the HCF of the three numbers is 3 square into 7, which is 63. So 63 is the greatest number that divides all the three of these, leaving the respective reminders. Express each of the following positive integer as the product of its prime factors. First one, 3825. So as it is a multiple of 3, I am starting with 3. 1275, again 5, 425, again 5, 85, 517 and 17 1. So 3825 can be expressed as 3 into 5 power 3 into 17. Second one, 5005, 1001, 1191, and then 7 13s are 13 1. So 5005 can be expressed as 5 into 11 into 7 into 13. Third one, 7429. Now this is a multiple of 17. So 17 437, and then 437 is a multiple of 19, 1923, and 23 1. 7429 is a multiple of 17 into 19 into 23. The traffic lights at three different road crossings change after every 48 seconds, 72 seconds, and 108 seconds respectively. If they change simultaneously at 7 a.m., at what time will they change simultaneously again? Now we have to find the least common multiple, that is LCM of 48, 72, and 108 first of all, to know the time when they will meet again. So LCM of 48, 72, and 108. When I do the prime factorization of 48, I get 2 power 4 into 3. And when I do so for 72, I get 3 square into 2 cube. And for 108, I get 3 cubed into 2 square. Now the LCM is 2 power 4 into 3 cube, which comes out to be 432 seconds. Now we are not supposed to leave this sum as 432 seconds. They have specifically asked as to what time, and we cannot also add 432 to 7 because this is not in its standard form. So we know that 1 minute is 60 seconds. So when you divide 432 by 60, you would get 7 as the quotient, and we will get a remainder of 12. So we have to add it to. So it would be 7 minutes and 12 seconds. So as the exact time is asked, the time would be 7:07 and 12 a.m. Determine the smallest three-digit number which is exactly divisible by 6, 8, and 12. So first we are going to take the LCM of 6, 8, and 12. 2 3s are 6, 2 4s are 8, 2 6s are 12. When I take for 3, I get 2 and 1. So the LCM is 2 cubed into 3, which is 24. Now I have to find the smallest three-digit number in the table 24. Generally the smallest three-digit number is 100. So I have to find 24 fours are comes out to be 96, 24 fives are 120. So 120 is the smallest 3-digit number exactly divisible by 6, 8 and 12. Find all the zeros of the polynomial x cube plus 3x square minus 2x minus 6 if two of its zeros are root 2 and minus root 2. So we are going to take this as f of x. When two of its zeros are root 2 and minus root 2, we know that x plus root 2 and x minus root 2 are factors of f of x. So naturally, x square minus 2 is also a factor of the polynomial f of x, right? Now we are going to divide f of x by x square minus 2. X cube plus 3x square minus 2x minus 6. 0x square minus 2x. This gets cancelled. 3x square comes here. This also gets cancelled and minus 6. So I should add a plus 3 here. 3x square minus 6 on sign change. All of them gets cancelled. Now I can express my polynomial f of x as x plus 3 into x square minus 2 according to the division algorithm. So x square minus 2 is already a factor of the polynomial f of x. So x plus 3 is also a factor of the polynomial. So x plus 3 is equal to 0, x is equal to minus 3 is the 0 of the polynomial. So the are root 2 minus root 2 and minus 3. If the polynomial 6x power 4 plus 8x cube plus 17x square plus 21x plus 7 is divided by another polynomial 3x square plus 4x plus 1, remainder comes out to be ax plus b. Now the divisor is given to be 3x square plus 4x plus 1. Dividend is 6x power 4 plus 8x cube plus 17x square plus 21x plus 7. What we're going to find is the remainder. So basically we have to do the whole division, then we'll easily get the a and the b value. So 3x square, I have to get 6x power 4. So I am going to add a 2x square with it. Adding, so I get 6x power 4 here and 8x cube here and 2x square. Changing the signs, this gets cancelled. I get a 15x square here plus 5. 5 threes are 15x square plus 20x plus 5. Subtracting it, I get 1x plus 2. So after this, the divisor is greater than the remainder. So we're going to stop the division. So we can easily see that 1x plus 2 is the remainder. I'm going to represent it as r of x. Now in the question, I have been asked ax plus b. The pattern is similar. Comparing the coefficients, I can easily state that a is equal to 1 and b is equal to 2. Find a quadratic polynomial, sum of whose zeros is 4 and one zero is 5. So, first of all, I have been given that the sum of the zeros of polynomial is 4. So, let alpha and beta be the zeros of the polynomial. Okay. So, let alpha be the 5. So, I have been given that alpha plus beta is 4, right? So, 5 plus beta is 4. Beta should be minus 1 then. This was easy. Now I should, but this was not the question, I should find the quadratic polynomial. Now a quadratic polynomial is basically expressed as x square plus sum of the zeros of polynomials of x plus product of the zeros of polynomials. It's minus the sum of zeros of polynomials plus product of zeros of polynomials. So sum of the zero of polynomial is already given as 4 to me. So x square minus 4x plus I have to find the product of the zeros of polynomials, alpha and beta. Alpha is 5, beta is minus 1. I get minus 5. So x square minus 4x minus 5 is the equation. If alpha and beta are the zeros of 2x square plus 5x minus 2, find the product of alpha and beta. Here we can easily get misled with the following expression 2x square plus 5x minus 2. We should always remember that the quadratic polynomial should be in the standard form ax square plus bx plus c. So 2x square plus 5x minus 10. We have taken it in the standard form. Now dividing by 2 wholly, I get x square plus 5 by 2x minus 5. Now I have been asked the product of alpha and beta. I always know that a quadratic polynomial can be expressed as x square minus sum of zeros of polynomial of x plus the product of zeros of polynomial. So comparing these two, I can easily find that minus 5 is the product of alpha and beta here. If alpha and beta are the zeros of the quadratic polynomial, f of x is equal to 6x square plus x minus 2. Find the value of alpha square by beta plus beta square by alpha. In all such sums, we are first going to take LCM. So, taking LCM, we will get alpha cube plus beta cube by alpha beta. Now I only know alpha plus beta, which is the sum of the zeros of polynomial generally given by minus b by a, which is minus 1 by 6 here. Alpha beta is the product of zeros of polynomials given by c by a, which is equal to minus 2 by 6 or minus 1 by 3 here. Now I only know alpha plus beta and alpha beta. Now I'm going to get this sum into the terms of alpha plus beta and alpha beta. So we have to remember the identity of a cube plus b cube here, which is a plus b the whole cube minus 3ab into a plus b. So just substituting a with alpha and beta, we get alpha plus beta the whole cube minus 3 alpha beta into alpha plus beta, and down we have alpha beta. Now what is alpha plus beta? Substituting it, we get minus 1 by 6 the whole cube minus 3 into minus 1 by 3 into minus 1 by 6. Our alpha beta is minus 1 by 3, which is minus 1 by 216. Now this is plus 3 by 3 into minus 1 by 6 again by minus 1 by 3. Here I get minus 1 by 216 minus 1 by 6 by minus 1 by 3. My bad, it's 3 minus 1 by 3. Taking LCM for 6 and 216, we get 216 itself minus 1. 6 into 36 is 216, so minus 36 by minus 1 by 3. We get minus 37 by 216 by minus 1 by 3. When I cancel 3 and 216, I get 37 by 72, which is the answer for this subdivision. The second subdivision, alpha by beta plus beta by alpha plus 2 into 1 by alpha plus 1 by beta plus 3 alpha beta. Here also again we are going to take the LCM. So taking the LCM for the first two terms first. So I'm going to take alpha square plus beta square by alpha beta plus 2 into taking LCM again for these two terms. I get alpha plus beta by alpha beta, and here I get 3 alpha beta. The sum is solved almost. Alpha beta. Now except the alpha square plus beta square, I have the values for all the other terms. So we have to now remember the identity that a square plus b square is equal to a plus b the whole square minus 2ab, right? So a plus b the whole square, we are just going to take a as alpha and b as beta. So alpha plus beta the whole square minus 2 alpha beta by alpha beta plus 2 into alpha plus beta by alpha beta plus 3 alpha beta. Now alpha plus beta, we know that alpha plus beta is minus 1 by 6 and alpha beta is minus 2 by 6, which is minus 1 by 3. So alpha plus beta is minus 1 by 6 the whole square minus 2 into minus 1 by 3 by minus 1 by 3 plus 2 into minus 1 by 6 by minus 1 by 3 plus 3 into minus 1 by 3. When I solve it, I get 1 by 36 here and plus 2 by 3 by minus 1 by 3 plus 2 into, when I divide these two, I get 1 by 2, which also obviously gets cancelled, and a minus 1 here. So I get 36 and 3. When I take LCM, I get 1 plus 24 by 36 by minus 1 by 3. 2 gets cancelled, plus 1 minus 1, both of them gets cancelled. 25 by 36 by minus 1 by 3. When I cancel the 3 and 36, I get 12. So the answer is minus 25 by 12.